This is the case study problem from the Russell and Taylor textbook. This problem is asking to assign these 6 students to these 6 different schools based on their priorities. For example, Amy wants to take a math class at the primary level in the morning and Monday, Wednesday, Friday, and it should be offered in Spanish. And this 6 school also has their preference of offering. So school 1 offers only math at the primary level in the morning, Monday, Wednesday, Friday, and Spanish and so on. So how do we increase the match for each of these students while you assign them to these 6 different schools? So we'll use the Microsoft Solver function to solve this problem. And to do that, we need to clean the data in a way so that the solver function understands. So we'll make a copy of this data and name this as clean. So as you have been seeing this, first thing we move these numbers away and then replace this with 0. It's not really necessary, but it's kind of make more sense. So Excel start with 0 assignment, and then we'll replace this number whoever best matches that particular school. For example, let's say Amy's best match is number 2. So it will run the condition that we give them, and the on condition we'll give them is this will be exactly equal to 1. Now a lot of these operations that I'm doing right now will make more sense towards the almost end of this problem. So just stay with me. It's gonna make much more sense why we're doing this. So we'll basically set this exactly equal to 1 so that each school is assigned, its students is assigned as well. Now we're going to count the preferences here for these different schools. So for example, if we send Amy to school 1, how many matches she's going to get, and we'll use a count function in Excel called count, and then there is a count match function. So we'll look for this into this array, and if it finds an exact match, then it will count all of them and give us that. Missing a bracket probably. So 5 match for if Amy goes to school 1. So as you can see, basically 100% match. There is only 5 options here. So now we're going to do the so we'll use this for all of these different students. So we're gonna basically freeze this cell so that we can copy that down, something like this. So as you can see here, this is already copied down for Franklin, Elena, and so on. So we're going to do the same operation for school 2, 3, 4, 5, and 6 for Amy and for everybody else. So Amy for school 2, and then here Amy for school 3. There could be a better way of doing this other than dragging and moving. And then Amy for school 4, and then Amy for school 5, and then Amy for school 6. I think I did everything correctly. Not this one. We drag it to Kelvin. That should be actually Amy's preference. Right. So looks like everything is done. So I'm gonna just test this guy. That looks good. It looks good for Franklin. School 4, school 3, school 2 for Franklin, and then school 1 for Franklin. So we get all the match. Now we'll do priority or match. We'll just write matched. We'll use that same function that we have been using for solving these problems. So you're gonna have sum product of this and this, and basically maximize this in the solver function. So now before we run this solution, I would like to keep a clean copy of this data. So we're gonna move this here. Now we'll name this as solution, and then go to solver function. We're going to optimize this cell and then maximize that, changing these numbers to whatever the best match is. You're going to use the simplex algorithm, and then constraint, you cannot send a fraction person, so that has to be a binary choice, either 1 or 0. And then this has to be exactly equal to 1. We're going to assign all these students, and then this also have to be exactly equal to 1. I think that's all the conditions we need, and simply hit the solve. It should give us a solution. Now I mean divide by 6 because we have 6 students. So that's the average priority. I think I divide by 4, should be 6. So that's the average priority for this solver. So which is pretty good. You only have 5 levels, so these assignments basically ensure at least on an average they get 4 matches, which is quite good. Now manually solving this would be a lot of work. You can also solve for the distance if you want. For example, we can create a function for distance. We can minimize the distance. We can simply write the sum product of these zeros comma this distance, and then we can optimize based on that. Now this one we can basically, before we run the solution, I would like to keep a copy of this. So we'll say solution distance. So we're going to optimize distance now. Very simple. So that's simply minimize the distance, changing these variables to either 0 or 1. And then number one constraint would be you cannot have a fraction person or fraction school, so that has to be definitely a binary choice. Then next would be all the students must be assigned to exactly one school, and then this should be exactly equal to 1 as well. That's what the problem is asking. And it's going to use the simplex linear, solve, hit OK, done. So now we're going to divide by 6. I'm forgetting that every time. So the average distance is now only 17 miles, but you can see their matches is really poor. In the earlier solution we saw the matches were up to 4 on an average, so they'll get 4 match basically out of their 5 preferences. On the other hand, if you optimize for distance, then they will get very poor match. That's the solution to that case study problem.